The screen shows the concentration of the PM2.5 and PM10 particles, as well as the strength of the Wi-Fi signal and the value of the supply voltage. Also at the right corner we can read the sleep time of the sensor.
Observe the concentration of PM particles during the day. In the development of this project, I was helped by PCBWay, which is one of the most experienced PCB manufacturing companies in China in field of PCB prototype and fabrication. If you want to make your own PCB for this project or for any other electronic project, PCBWay is a great choice. They have a large online community where you can find the open source project, and you can also share your project there. From my personal experience, I can tell you that on this community you can find many useful projects with already designed PCBs from where you can place an order directly. Also, you can get 10 PCBs for only $5. So if you want your PCB, just type PCBWay.com on your browser.
Hello, this time I will show you how to make a device that monitors the quality of the fine dust particles in the atmosphere. It measured both PM10 and PM2.5 particles, uses the Nova PM SDS011 laser-based sensor. This sensor has a built-in fan which greatly simplifies construction, and it has built-in logical level serial communication, providing direct reading of the PM2.5 and PM10 values without having to use the maths to manipulate PWM values to obtain the results. The sensor itself is delivered together with an USB to serial converter, so we can connect it directly to the USB port of the PC. In that case, we need to use appropriate software that we can download from the sensor manufacturer's website, which is given in the text below. So this is the manufacturer software. First we need to choose appropriate sensor, in our case SDS011 laser PM2.5 sensor. Next, serial port. As we see on device manager, our serial port is COM21. We can choose COM21 in device list and press OK. Now we choose PM2.5 and PM10 for selected devices. Red line is PM2.5 and blue line is PM10. Now let's make some particles near the sensor. And we can see results on the graph. The device that is presented this time works independently, so it is completely flexible in terms of installation location, size, as well as the cost of the entire device. The results are displayed on the 2.5-inch TFT LCD display, but also, thanks to the use of the ESP8266 Wi-Fi module, is sent to a Windows PC running a small server application to log the data on a chart to be viewed on the application itself in a web browser, or in a web browser, either on the PC over the internet. So the PC needs to have the static IP address set up in this network properties setting. One thing to note is that the sensor has a certain lifespan, and the datasheet claims up to 8,000 hours. If you run the sensor continuously, that's not quite a year, so you might want to think about how often you will power off the device. According to the code, the sensor is active for 30 seconds while taking a reading, then shuts down completely for 4 minutes and 30 seconds. The active period of the sensors is indicated by this red LED. Instead, to put the sensor into a low power mode, there is a chosen to simple switch off the sensor's main power through a small MOSFET transistor. I just want to mention that in order to compile the code without errors, you need to install 2.7.4 ESP8266 Arduino Core version. This time we will not dwell on the way to install the ESP8266 board definitions into the Arduino IDE because it is explained in the previous videos. The hardware part of the device is relatively simple to make and consists of several components. ESP8266 based microcontroller board, in my case NodeMCU 1.0. Next, Nova PM SDS011 laser based sensor, 2.8 inch TFT LCD display. Next, 2N7000 or similar small MOSFET transistor, save data button, and couple of resistors. The sensor is placed on the outer back of the case so that it can be maintained more easily, and also the results obtained are more accurate. When the device has to measure pollution outside, a situable tube is placed leading to the external environment so that the whole device is protected from negative atmospheric influences. Now let's see how the device works in reality. When turning on device, it first connects to the local Wi-Fi network with the appropriate username and password that we previously entered in the code. Data is sampled every 5 minutes, so as there are approximately 300 points across the display, the histogram plot represents approximately 24 hours of data. So it needs to pass a certain time to graph to start forming. As I said before, this red LED signals that when the air pollution sensor is active. The screen shows the concentration of the PM2.5 and PM10 particles, as well as the strength of the Wi-Fi signal and the value of the supply voltage. Also at the right corner we can read the sleep time of the sensor. As we see, the color of the graph changes from light green through yellow-red shades to magenta, depending on the air pollution according to UK DEFRA scale. Now sensor is active and perform measuring. These are new values. We can also observe this graph on PC using the application Air Quality Monitor, which you can download below.
After installing the program, we need to make the simple settings. First, as I mentioned before, we need to set the local IP address that is previously defined in the code. In the system settings tab, we also need to enter a port given earlier. In our case, it is 8802, and this is local IP address. Then in the chart settings tab, we adjust the titles and shape of the graph. And finally, in the Air Quality tab, we can graphically observe the concentration of PM particles during the day.
And now let's briefly follow the process of making the device.